Okay, we're in the examples now, and we're going to go through one example at a time. And I do want to point out, I realize for some students, lecture can go really quick sometimes, and they have a hard time following. And if you look on the side of these little examples we give you, there are videos here. If you need to go back and review, it's not a bad place to review. But this is lecture. We're going to go through that lecture now, and we're doing the examples from the lecture. So if I were doing this problem over here, the question is, how would you do that? Well, we might be sticklers over here, but we do want you to rewrite it, right? So I'm going to rewrite it. So it's an improper integral. By the way, we're going to infinity, and this function is defined in that complete interval over there. If you looked at it, it's easy to look at, but it's just 1 over x. That's something we've been doing for a long time now. So I'm going to write it as limit as, I don't know, a maybe goes to infinity. And what do you get over here? You get 1 to a, 1 over x dx. Well, this is fairly easy to do. This is limit a goes to infinity. The antiderivative of 1 over x is the natural log of the absolute value of x. The limits of integration are going to be from 1 to a. All right, let's keep going. Whoops. Equals limit a goes to infinity, the natural log of the absolute value of a minus the natural log of the absolute value of 1. All right, what happens here? Well, as a goes to infinity, the natural log goes to infinity. Wow, it blows up. What does this mean? It's divergent. Now, if you remember when we introduced the comparison theorem, we actually used that and we said it was divergent. It clearly is. We just showed that. All right, so here's some little blue work over here for you. And again, they put the same thing down. Mine might be more dragged out. So let's do number 2. And I'm looking at number 2. And they want me to show it's equal to pi over 2. And the way we're going to do that is one step at a time. So I'm going to write the integration down. It's going to be 0 to infinity, 1 over 1 plus x squared dx. By the way, this is defined on the entire real number line. So it's going off to infinity. So I need to write down it's improper. And I'm going to say a goes towards infinity. This would be 0 to a. You should recognize that guy, and you should know its antiderivative, something covered in math 121, and certainly reinforced in this class many times. That's arctangent of x, limit of integration 0 to a. Let's keep going. Limit a goes to infinity, arc tangent of a minus arc tangent of 0. Well, the arctangent of 0 is easy. That's 0. Then the question is, what's the arctan of a if a goes to infinity? Well, you should have a good idea that the arctangent function looks like this, and it's asymptotic with pi over 2. So the answer over here is pi over 2. All right, pretty simple. Go back over here. Again, they put the area, my key in the blue area is what I'd write down if I typeset it. All right, let's do this one over here. They want me to show it's equal to 1. And again, 1 over e to the x is defined for all real numbers. So I'm going towards infinity. That's why it makes it improper. So I'll write this over here. This can be 0 to infinity. And that's 1 over e to the x. I'm just going to put down e to the minus x dx. This can be written as a limit as a goes towards infinity. And I think I can do that. And that's going to be 0 to a e to the minus x dx equal limit a goes to infinity. And that would be minus e to the minus x, limits of integration 0 to a. Let me write this down. Yeah, I know it's a lot of work. Limit a goes to infinity minus 1 over e to the a. Minus a minus is plus 1 over e to the 0. Well, as a goes to infinity, that first term disappears very quickly. And 1 over e to the 0 is 1 over 1, which is 1. That's what we're supposed to show. And we just did that. All right, not bad. So far, the problems are kind of moving along smoothly. And let's go to the next one, number 4. And number 4, they want me to show that this is the case. I'm looking at it's defined for all real numbers. So it's improper. And I'll write this down for you. And that's 1 to infinity. 1 minus x, e to the x, dx, equal, limit, I'm going to say a goes towards infinity, 1 to a, 1 minus x, e to the x, dx. Okay, here's my trouble. I got to do side work. And what I'm trying to do in my side work is this integral over here, which is e to the minus x, e to the minus x, dx. I'm trying to do that. And the first guy looks pretty easy to do. It's just simply, if I wrote that down, it's minus e to the minus x. And then I get this over here. And this one is going to be a little bit more challenging for me, but not substantially so. And I got to do that. And again, certainly I'm doing work, and work is always a problem. And you might make a mistake in it. That's why we provide a key for you. So I'm going to say, I'm going to use the integration by parts. Let me just point out what I mean by that. I'm doing x e to the minus x dx. I'm going to say u is equal to x, dv equals e to the minus x dx, du equals dx, v equals minus e to the minus x. All right, let's put this down. So minus x e to the minus x, we'll simplify this later. Minus a minus is going to be plus e to the minus x dx. All right. Well, let's see if we can do that. And what do you get over here? Well, you get, let's put it down. You get minus e to the minus x plus x e to the minus x. And then what are you going to get over there? You get minus plus. Did I do that right? Plus minus e to the x. Yeah, plus e to the minus x. What's that going to be? X e to the minus x. All right. I'm going to check it. I'm going to check this, make sure I got it right. And so if I differentiate that, what would I get? I would get x e to the minus x like that, and then plus e to the minus x. I'm sorry, minus. Second, I got to do something here. Oh, no, I get that. Yeah. So what does this give you? Minus x over e to the minus x plus 1 over e to the minus x, which would be, it looks like beautiful. So I write this over here. A little side work's probably more work than the problem's worth. So limit a goes to infinity. Antiderivative is x e to the minus x. I'll just write down this way over here. Limits of integration are 1 to a. Got to keep going forward. Limit a goes to infinity. You would get a over e to the a minus 1 over e to the 1. And what does that give you? Minus 1 over e. Let's make sure I didn't make any mistakes over here. Oh, no, we did okay. All right, so we got this, and we did this work over here. And again, I got the antiderivative there. I plug it in here. All right, let's do this one over here. It looks a little strange, but this one says it's equal to pi over 2. That seems strange, but anyway, let's take a look at it. And this has got, it's continuous on all the real numbers, but we're going towards, two extremes. So it's going to have to be split into 2 parts. Put this over here, minus infinity to infinity, e to the x, 1 plus e to the 2x dx. Well, my first goal is just to write it. down in the proper form. So I'm going to say, minus infinity to some number between minus infinity to infinity. I'm going to pick 0. And that would be e to the x, 1 plus e to the 2x dx plus, well, I'm going to start at 0 again, go off to infinity now. And what do you get? E to the x, 1 plus e to the 2x dx. Let's keep moving. And I'm going to write this as a limit problem now. Limit as a goes towards minus infinity, a to 0, e to the x, 1 plus e to the 2x dx plus, well, I'm going to use a different letter. I'm going to put limit as b goes towards infinity, 0, b, e to the x, 1 plus e to the 2x dx. All right. I'm going to do a little side work. I'll tell you what the side work I'm going to do. It's going to be side work now. Not everyone needs to do side work, but I want to encourage it. So I want to do this over here. I'm going to use u substitution. I'm going to say u is equal to e to the x, and du would equal e to the x dx. So what do you get over here? 1 du, 1 plus u squared. Well, that was easy. This guy's antiderivative is going to be arc tangent of u plus c. Well, what's u? It's e to the x. No, I'm ready to go back over here. That worked out pretty nice, right? So what do you get over here? This is equal to limit. A goes to minus infinity. Arctan e to the x, limit integration a to 0. We'll do that later. Plus limit b goes to infinity. Arc tangent e to the x, limits integration 0 to b. All right, remember, you're getting credit for all the work you can put down if it's correct. Limit a goes to minus infinity. Oh, this is going to be a tough one, right? So arctan, what's e to the 0? It's 1 minus arc tan of e to the a, right? Plus limit b goes to infinity. Let's see if we can do that. Arc tan e to the b minus arc tan e to the 0 is 1, right? All right, it's probably, I really mean that. So I'm going to see if I can do it. And, I'm going to clip off one thing at a time. That's going to be pi over 4. Minus, let's see if we can do this guy over here. And a is going to minus infinity, so that'll be arctan of e to the minus infinity, which is going to be 0. Arctan of 0 is 0. I'll put that down. All right, let's do this limit b limit now. And this is going to be b goes to infinity, so e to the b goes to infinity. And the arctan of an infinity, we just did that's pi over 2. Minus, let's see what we get over. I'm sorry, this is plus. I'm sorry about that. Minus the arctan of 1, which is pi over 4. Well, I got to do some arithmetic now, don't I? Well, what's nice, the pi over 4 disappears and left off with pi over 2. What did they say we were supposed to get? Wow, we did it. And again, the work all typesets there for you. Okay, that's number 5. And let's go to the next one. And let's take a look at it. And I'm going to blow it up. And this got problem at 0, right? So I'm going to say this over here is going to be the limit. I'm going to use a. And we're approaching 0. I want to point out we're on the interval from 0 up to 2. It's not defined at 0. So what side? The right side, right? And there's going to be an integration from a to 2 x to the minus 3 dx. Let's see if we can do that. Limit a goes to 0 from the right. The antiderivative thing is going to be what? X add 1, so minus 2 over minus 2. So I'll write this over here. And that's going to be from a to 2. All right. Let's see if we can do that. Limit a goes to 0 from the right. The upper limit would be minus 1 over 8. Minus a minus plus 1 over 2a squared. All right, what happens when you approach 0 from the right side? Well, the first term is going to be minus 8, but the next term, if you approach 0 from the right side, you'd get 1 divided by a 0, which is infinite. D&A, divergent. All right, look at the K. And again, the reason for looking at the key is I want to make sure that, what my chicken scratch is being represented accurately over here. And you should look at that. All right, so that we did okay with that one. Let's look at the next one. And I'm kind of looking at it and I'm wondering what to do and how to do it. But I do know one thing about this guy over here. There's trouble at 0 and there's trouble at infinity. So this is going to require some rewriting. But before I do that, I want to do side work. And my side work is just going to be, could I integrate this guy? So let's take a look at it. And I don't know, I'm gonna try something. I'm gonna try u equal root x. Now give it a shot. If it doesn't work, it doesn't work. It's not, no time lost. What do you got over here? Du would equal 1 over 2 root x dx. Well, this is getting sort of good. I'll write this over here. So 2 du would equal 1 over root x dx. And then what do you get? This is kind of weird, right? So you get u squared would equal x. So I'm going to see if I can do it. All right, so I'm going to see if I can do this over here. So I'm going to say that, this, and I'll write the, I'll kind of circle it for you. This is equal to what? It's 2 du's, right? And then they got this x plus 1 in the bottom, and that's going to be u squared plus 1. And I think I can do that. I'll tell you why. It's one I can recognize. So really this thing's going to be equal to 2 arc tan of, what's u? It's root x plus c. So I can definitely do the antiderivative, and I'm glad for that. So what I want to do is I want to go back over here now and split into 2 problems. And the 2 problems are as follows. So this integration over here, 0 to infinity, 1 over root x, x plus 1 dx is going to be split into problems. The first problem is going to be the limit as a approaches 0 from the right side of this integration. All right. Whoops, sorry about that. I jumped the gun on that one. Let me just put that down for you. I got to get my eraser out. Sorry about that. I said it's going to split into 2 things. So I'm going to put a here. And then I want to pick a number from 0 to infinity that would be easy for me to choose. I'm going to try 1. Plus the limit as b goes towards infinity. I'm going to start at 1 and go to b, and this will be 1 over root x, x plus 1 dx. And I do realize for a lot of students, it's the amount of writing for them is overwhelming. But you have to realize, to get to that, um, I'd say a good paying job, you got to learn to write things down and communicate. I'm not saying in chicken scratch, you really need to learn to type it up, but right now I'm doing okay with this. So do I remember that the antiderivative over there? And it's 2 arctan, right? Of the root of x, limits of integration are going to go from a to 1 plus, let's put the next limit down. That's going to be the limit. B goes to infinity. 2 arctan root x. Limit integration over there going to be from 1 to b. I got to do some work now. Equals limit. A goes to 0 from the right side. 2 arc tan. Well, root of 1 is 1, right? Minus 2 arc tan. And that would be the root of a, right? Yeah, let's keep going. Plus limit. B goes to infinity. 2 arc tan of b. I'm sorry, not b. It's root b. Sorry about that. Minus 2 arc tan. Root of 1 is 1. Let's see if we can do it. And the first guy's pretty easy. This guy over here. That's going to be 2 times pi over 4. Minus, well, this is going to be the, this limit's defined. The root of a is a goes to 0 from the right side is going to be 0. Arctan is 0 is 0. So I'm going to put 2 times 0 down. All right, that's the first limit done. Let's do the next one. Now, as b goes towards infinity, the root of an infinity is infinity, and the arctan of an infinity is asymptotic with pi over 2. Minus, oh boy, 2 arctan of 1 is pi over 4. Okay, some work to be done, and I'll go through the work with you. I get pi over 2 minus 0 plus pi minus pi over 2. And this gives me pi. All right, conversion. By the way, mistakes happen, and I realize that. I mean, all that work, and you might say, did I get it right answer? Well, I'm looking at it. And by the way, I want to point out, I do type it up for you, and probably should look at types at work. All right, I did my work on the side. That's my exam work would look like that. If I were doing homework, it would look like this over here. And then if I were submitting my homework for grading, I would type it up and it would look like this over here. All right. All right, this one over here. Now, this is a tough question now, and it kind of reminds me of, can I solve this? And this can get really tough, by the way. So I'm going to say there's multiple ways of doing it, but they want to solve it. And this can get really, really tough, by the way. So I'm going to write this over here. This is 1 over e to the x squared. That's the left side. And this is the right side. Well, what I notice about this thing is it's always going to be positive. I know that much. So this is going to be a lot easier for me to write this down. And I'll write this over here. And this will be e to the x squared. All right. So I'm going to claim that's not so bad to write down. And then what I know about this over here, if this is to be true, what do I know? I know that this has to be met. Then what am I going to do? I'm going to go back in 119. What I did in 119, I would have made this 0. This would be x squared minus x, 0, x minus 1. I'd put a number line down, list the zeros at 0 and at 1. Well, at 0, it's true. At 1, it's true. And then I got to do sign analysis. I'll point out what I mean by that. You pick a number here, like 2, plug it in. That would be positive. Positive, positive, positive. That's certainly greater than 0. I would shade that in. All right, let me point out what I do over here. I take a number over here. Someone says, well, let's do this first. Let's take a half. That would be positive. That would be negative. So this would be negative. I wouldn't shade that in. Let's take a number over here like -1. That would be -1. That would be -2. Well, -1 times -2 is a positive number. So I'd shade this in. So the solution to this problem over here is going to be from -infinity up to 0, inclusive, union 1 to infinity. Let's check the key. And I'm seeing that there. That's good news. All right. Now, someone says, that seemed like an odd question to have there. And it might have been an odd question, but it has something to do with the next question. Something to do with the next question. All right. So the next question has something to do. Number 9 has something to do with number 8. I want to claim over here, there's not much you can do about this integration. You're not going to get it. All right. Now, by the way, when I say that, it is doable, but not at this level. You haven't seen this yet. All right. But this is doable. You can actually integrate this and get a number for it. You just don't have a technique for it at this point. All right. So what I'm going to claim over here is I'm going to say I can't do the integration, but I might be able to do a comparison. So I'm going to write this over here. I'm going to write 1 over e to the x squared, and I'm going to compare it to something. And I have to say it probably has something to do with their other problem over here, which is 1 over e to the x. All right. Now, what do I know about that? I know this. How do I know that? I just did it. I just did it. So what would I know about this one over here? Well, I know this then. Whoops, I didn't mean to put that down. Give me a second to erase that. So what am I really doing? I'm making a comparison. If I can show that this is convergent, by the comparison theorem, this would be convergent. So let's see if we can do that. I want to see if it's convergent. So let's put this over here. I'm going to show, is this convergent? If not, I get troubles though. All right, as a limit, a goes to infinity, 0 to a, e to the minus x dx equals, let's write this down, limit, a goes to infinity. This is going to be minus e to the minus x, 0 to a. And what's this guy over here give me? Limit, a goes to infinity, minus 1 over e to the a, minus the minus is plus. Well, that's going to be, 1 over e to the 0, which is 1. And what does this limit produce? Well, if a goes to infinity, this will go towards 1. So what have I shown? This is convergent. So if this is convergent, the other one is convergent, and that's not bad. All right. So I do want to recommend that you kind of read through this. Oh, I made a mistake. And I want to point out the mistake was, and this is unfortunate, and I want to communicate that to you. I made a mistake. This is true, not on that entire interval. It's only true from 1 out to infinity. So I'm sorry, I have to rewrite that, and I apologize. So what am I going to do over here? I'm going to write this over here, 0 to infinity, 1 over e to the x squared dx should be written as 0 to 1, 1 over e to the x squared dx, which is a finite number. This is finite, plus 1 to infinity, 1 over e to the x squared dx. And then what you have to do is you have to show that this is convergent by doing a comparison. Let me write this down for you. So 1 to infinity, 1 over e to the x squared dx is less than or equal to 1 to infinity, 1 over e to the x dx. Let me do that integration. I'll write this down over here for you. Limit. And again, I want to show this is convergent. This is true, by the way. I got to cross this out over here, though. I'll point out this stuff over here is not true. Not true. All right, not true. Cross it out. And yep, I crossed everything I needed to cross out. So it's going to be limit a goes to infinity. And you're going to get 1 to a. That's going to be e to the minus x dx equals limit a goes to infinity. That's going to be minus e to the minus x, limit integration 1 to a. Let's keep going. Limit a goes to infinity. And let's write this down. It's going to be minus 1 over e to the a, right? And then it's going to be minus a minus, which is plus 1 over e to the first power. And if you do that limit, you're going to get 1 over e, all right? That's a convergent number. It's finite. So this is true, all right? So this converges, all right? And again, I apologize for not, and after doing all that work too in number 8, I should have realized it's only true for 1 to infinity. So I did split it up for you, and then I kind of did that, and I did that convergence for it's 1 over e, all right? Let's see if there's anything else. And, oh, number 10. By the way, there's a visual of these things over here. And I hope you realize what the visual is. I'll outline this for you. The reason they give you a visual, a lot of students, the visual learners, I like to look at things visually. So I'm going to, visualize this guy here. What's e to the minus x? It's this picture here. And I want to visualize the other one, which is this guy over here. And this is this visual right over here. Okay. Now the question is, I'll write it down for you. When is e to the minus x squared less than or equal to e to the minus x? Well, looking at it, I want to point out it's going to be true here. The blue curve is definitely below until we get up to that point over there. And the blue curve is below over here. So just looking at it visually, what's that going to be? Minus infinity up to 0 inclusive, union 1 off to infinity. And that's what we did by hand computation. Okay, so next thing up, number 10, last question. It says the solid form by revolving the region 1 over x and the x-axis for x greater than or equal to 1 is called Gabriel's horn. A little footnote over there. If you want to read about that, you can. And then it says, what's most weird about this object is that it can be shown to have finite volume, but its surface area is infinite. Set up and evaluate an integral for its volume and verify its pi. So I'm going to put this down for you. And f of x is equal to 1 over x. And we're on the interval from 1 to infinity. Let me put this down for you. What does the graph look like? This over here. We're starting at 1. This is the region. What are we doing with the region? We're rotating it, and we want to get volume, right? So this rotation is going to look like a disk, where this is the radius, this is the thickness dx. Let's write the integration down. What's it going to be? We're starting at 1, going to infinity, and this is going to be a disk method. So what do you get? Pi r squared. What's r? 1 over x. Thickness dx. Well, let's go to town. See if we can do it. Limit as a goes towards infinity, 1 to a, pi x to the minus 2 dx equals limit a goes to infinity. Let's see, pi, that'll be x to the minus 1. So this, I got this over here. So 1 to a. Let's see if we can do that. Limit a goes to infinity minus pi over a. Minus is plus pi over 1. Limit's fairly easy to do. When a goes to infinity, first term disappears. And we're left off with pi. That's pi cubic units, by the way. What did they want me to do? They want me to show me it's equal to pi. And again, the work is all written up there for you. All right, so what do you have to do now? And I really can't say this enough times. The student said, I don't think I need to do anything. Well, it's not going to work for you. You need to work. What do you need to work at? Working problems. What problems do we recommend you do? These problems over here. Thank you so much for paying attention. And again, if you need any help or assistance, please feel free to come by during office hours, and I'll be more than happy to help you.